The last part of stoichiometry, we deal with the relationships between the moles, mass in grams, volume in liter, and the number of molecules. So, in a balanced chemical equation, we can relate the coefficients of the reactants or products to the number of moles. For example, in the balanced chemical equation, let us say aluminium solid reacting with sulfuric acid to give aluminium sulfate and hydrogen gas. If we balance this equation, we get 2 aluminium solid reacts with 3 sulfuric acid to give 1 Al2SO4 and 3 H2. This is the balanced equation. This means that 2 atoms of aluminium is required to react with 3 molecules of sulfuric acid, and it produces 1 molecule of aluminium sulfate and 3 molecules of hydrogen. These coefficients, these numbers which are called coefficients, these are equivalent to the number of moles. So we can also say that 2 moles of aluminium reacts with 3 moles of sulfuric acid to give 1 mole of aluminium sulfate and 3 moles of hydrogen. Because molecules is a count and moles is also a count. So we can just relate them. Now, we know that there are relationships between mass in grams, volume in liter, and also the Avogadro number with the moles. These relationships, these 3 relationships, out of that, 2 of that I have already given to you in the last 2 parts, and the third one I am explaining to you here. So here, 1 mole of any substance, we know its mass will be its molar mass in grams. 1 mole of any substance will weigh its molar mass in grams. For example, 1 mole of aluminum will weigh its atomic number in grams, like that. And then another relationship that we already know is that 1 mole of any substance contains Avogadro's number of particles. So if I take 1 mole of aluminum, it will contain 6.023 into 10 raised to 23 atoms of aluminum. That is the meaning 1 mole of any substance contains Avogadro's number of particles. Now there is one more relationship between mole and volume. So that is only for gases, because it is much easier to measure gases in volume rather than mass. We need a relationship between moles and volume. So that relationship is 1 mole of any gas at STP, standard temperature and pressure, will occupy 22.4 liters in volume. So with these 3 relationships, we can get a way of converting between moles to mass, mass to moles, moles to volumes, volume to moles, and moles to number of molecules or number of molecules to moles. So these are possible using this relationships. See, according to this flow chart, it is easy to know that if you have the number of moles of any substance, you can find the mass of that substance in grams by simply multiplying with its molar mass. Or if you have the mass in grams of any substance, you can get its number of moles by dividing by its molar mass. Similarly, if you have the volume of any gas at STP. At STP, it is important. It should be at standard temperature and pressure, not at any random temperature and pressure. So if you know the moles of a particular gas in the chemical equation in STP, at STP, then to convert it into number of moles, we can just divide it with 22.4 and you will get the moles of that gas, or if you have the moles of a gas, you can get the volume in liter by multiplying it with 22.4 liters. Similarly, if you have the moles of a substance, you can find the number of molecules of that substance by multiplying with Avogadro's number, which is 6.023 into 10 raised to 23. And if you have the number of molecules of any substance, you can convert it into moles by dividing the number of molecules by Avogadro's number. So Avogadro's number, basically it is, Avogadro's number is 6.023 times 10 raised to 23. That is Avogadro's number for use in multiplying. Now, why do we need this relationship? Because when you are given a balanced equation, the coefficients will tell you the number of moles. It will only tell you the number of moles. But when we want to do the calculations, we need to find either the value in mass in grams or in volume. These are the two which we most commonly require. Sometimes we need to find the number of molecules, but mostly if we know the number of molecules, we need to convert it into number of moles, and from there go to mass in grams or volume. So these three relationships on this flow chart, which contains the relationship between moles, volume in liter, number of molecules and mass in grams, will help you to convert between the quantity of any two substances in stoichiometric calculations using balanced chemical equation. Let us see one example here below. So suppose there is the reaction of aluminium with sulfuric acid to give aluminium sulfate and hydrogen gas, and we are doing the reaction with 2 grams of aluminium. So if 2 grams of aluminium is treated with a certain amount of sulfuric acid, okay, and aluminium here is the limiting reagent, then what volume of hydrogen will be produced at STP? That is the question. So if 2 grams of aluminium solid is reacted with excess of sulfuric acid, what volume of hydrogen gas will be produced at STP? So here, the first thing to do, as always, is to write the balanced equation, which we have already written on top. So we will just repeat it here again. So it will be aluminium plus sulfuric acid, H2SO4, giving aluminium sulfate, Al2, SO4 3 times, plus hydrogen gas. And as before, for balancing, we need 2 aluminium solid, sulfuric acid is aqueous, we will get 3 here, so we will have 3 here. Okay, this is gas and this is aqueous. Alright, so we have the balanced equation and we are told that excess of sulfuric acid. Therefore, we do not have to consider the coefficient of sulfuric acid for our calculation. It is in excess. Aluminum is the limiting reactant. So we just need to know the ratio between aluminum and hydrogen. So the mole ratio of aluminum to hydrogen is, aluminum is to hydrogen is 2:3. 2:3. We know that we are given 2 grams of aluminum. So first thing that we have to do is to convert the mass of aluminum to moles of aluminum. We have to convert the mass of aluminum to moles of aluminum. So convert it into moles. Then from there we can find the moles of hydrogen by the mole ratio, as we have done before in part 1 and 2 of stoichiometry. So 2 grams of aluminum, we have to convert it into moles of aluminum and then use the mole ratio to convert it into moles of hydrogen produced, and then convert that into volume of hydrogen at STP. So these are the steps that you have to use. Now, from the flowchart above, we can see that in order to convert the mass of aluminum to moles of aluminum, we have to follow this step. Divide by the molar mass and we will get the moles. So we have to divide 2 grams with the atomic mass of aluminum and you will get the moles of aluminum which you are using in the reaction. Then we have to use the molar ratio 2:3 to find the number of moles of hydrogen. We are still here. And then from the moles of hydrogen, we have to multiply by 22.4 in order to get the volume in liter at STP of hydrogen gas. So this is the way to proceed. So for this, we need to know the atomic mass of aluminum and also 22.4. That's all. Okay, so we can do the calculation. So we can do the calculation as follows. 2 grams of aluminum divided by molar mass of aluminum, which is 26.98. So you can write it like this. This is a better way of writing because then it is clear that 26.98 is the mass of 1 mole of aluminum. So times 1 mole aluminum divided by 26.98 grams of aluminum times the mole ratio. That is, we want hydrogen, so we put hydrogen on the numerator, divided by, we are having aluminum in our quantity, so 2 moles of aluminum in the denominator, multiplied by 22.4 liter of hydrogen, because that is the volume for 1 mole. So for so many moles, you have to multiply with 22.4 divided by 1 mole hydrogen, which is the number of moles in 22.4 liter, and the answer will be 2.49 liters of hydrogen at STP. And that finishes the stoichiometric videos. Thank you.